Hello and welcome to How Do I BI, a mini-part screencast series on using SQL Server Analysis Services 2008. This is a companion to the book Smart Business Intelligence Solutions with Microsoft SQL Server 2008. I'm Lynn Langett, a developer evangelist with Microsoft in Southern California. In this edition, we're going to talk about understanding the Cube Editor Dimension Usage tab in BIDS. Before we go to the screencast, I want to talk about FAQs and gotchas. The first and most important when building OLAP cubes is to keep the relationships as simple as possible from source data. You're probably going to want to refer to the modeling chapter in the book referenced in the beginning of the screencast to better understand star schemas. We will be taking a look at the different types of relationships between dimension and fact tables as implemented in BIDS in the screencast. Star schemas are always the preferred method because they're simpler to build, load, maintain, and so on and so forth. There will be situations and business reasons to use non-star schemas, and again, those are detailed very thoroughly in the book. We're going to focus on the implementation rather than the business reasons. Another FAQ is to keep fact tables as narrow as possible and refrain from building dimensions from columns in the fact table. A common example of this is something such as the sales order number. If this is a business requirement, be sure to validate it and look at the number of end users that are going to need this. Any dimensions that are built from the fact tables significantly widen the fact tables, and of course they're the largest tables that are part of the OLAP cube in terms of size, so you want to be very conservative in retrieving dimensional information out of fact tables. You want to take a very thorough look at the samples to understand the types of relationships that can be used when setting up your source data. It's a really important tip when you're trying to learn star schema modeling. There are some gotchas. Some dimensions may not be associated with some measure groups, and that might seem like a strange concept, but starting in SQL Server 2008, you could associate more than one fact table with a single cube. The reason for that is so that one large cube could represent the majority or even all of the business results for a consolidated all-up view of what was going on in the business. It's also important that you verify each relationship in this view to make sure that it is set at the level of granularity that is required by the business requirements. An example of this would be time. In some cases, reporting might need to be done on a day-by-day basis. However, in other cases, I can think of a specific business example around restaurants, the reporting might need to be done at a more granular level, say hour or even down to the minute. We're going to go ahead and go over to the screencast now. Screencast, we're going to take a look at the structure of an OLAP cube. We're working in BIDS and we've opened up the AdventureWorks solution and we've double-clicked on the sample included cube AdventureWorks in order to take a more detailed look at two of the designer tabs so that we can understand the structure. The first one is in fact called Cube Structure, and if you pass your mouse over it, you can see it has the tooltip. Use this view to build or edit measures in the cube. So it looks very much like the data source view that we saw in a previous screencast. However, the primary purpose of this designer is for you to be able to work with measures. So let's take a look at some existing ones before we build a new one. If we open up Internet Sales, this is a measure group, and this is a single fact table generally that contains source data that will be populated as facts into the destination cube. There are two types of measures included. There are measures which are directly retrieved and stored, and those are shown with the four bars here. And if we click on Internet Order Quantity and then we go over to the properties, we can see if we drill down to Source that it's directly retrieved out of a fact table. And if we click on the ellipse here, we can see that it's simply the order quantity column value out of the fact internet sales table, and it's bound by a direct column binding. If we click the drop down here, we can see that we could generate a column, or we could even have a row binding. We have some different varieties in modeling available. The other type of measure that is included in the cube is what's called a calculated measure. And this is analogous to a calculated cell in Excel. The difference, of course, is this is calculated in a multidimensional destination structure. And this one is called Internet Sales Amount. If we go over to the properties for this and we open the ellipse for the source, we'll see that this is column bound. However, if we open up the source and we drill in a little bit further down, we will find that this is actually calculated And here it is under the measure expression. So if we open the measure expression, you can see this is a calculation that's done at the time of query. This is really important in understanding when building cubes, the balance between storing information, which requires additional disk storage space and processing time when the cube information is updated, versus calculated information. It is quite common to have a large amount of calculated measures in a cube, in the tens or even hundreds of calculated measures. Again, for more detailed information, do consult the book that I talked about in the beginning of the screencast. This is really an implementation screencast more than anything else. So if we wanted to add an additional measure, we would simply click right on this button inside of the cube structure, and then we would select the source table. Again, if you're following the naming conventions of fact and dimension, it's a little bit simpler when implementing this. The column, and then the usage, which is the aggregate. Now there are many aggregates that are included. The sum is the default. You can see other things like count, min, max, so on and so forth. It is possible also to define custom aggregates for an entire measure or for a subset of a measure, and in a subsequent screencast when we cover calculations in a cube, we'll take a look at that. So it's as simple as that to add a measure. Now once you've added your measures, then you're going to want to construct your cube, and you can kind of think of this as the sides of a Rubik's Cube. It's probably the best visualization that we have. It's a little bit inadequate because cubes can have certainly more than 3 dimensions. They're called n-dimensional structures. We're going to go to the Dimension Usage tab and take a look at it. The Dimension Usage tab shows the intersection between the various dimensions. These are down to the left side, and the measure groups which have been defined in the previous section. So you can see for the sample cube, we've got measure groups that relate to the sales that we've made of our product over the internet, and the sales that we've made through resellers, and some other information about our sales targets and goals and financial reporting. So we're going to cancel out of here, and we could also filter by just turning this off or on. We're going to cancel out of here, and then we're going to take a look at how the dimensional information intersects or is joined to the measure information. And we'll start with promotion. So for the promotion dimension, for the internet sales information, this promotion square represents the relationship. When we pass our mouse over it, we see that it's regular, which is the analysis services way of saying a star relationship. And if we click on it, there'll be an ellipse that will be available, and then we click that to open and edit and view the relationship. And we can see that this is shown as a regular relationship, which is otherwise known as star. We have a little visual indicator over here showing that the dimension table is joined directly to the fact table. An important consideration, in addition to the type of relationship, is the granularity attribute, and I had mentioned this in the opening to this screencast. In this particular case, we're joined at the level of the individual promotion, and you can see these are the various columns from the promotion source table, and you can see the relationship here is a primary key, foreign key, from the source to the destination table. If we click on Advanced, we can see that we have the ability to specify null processing behavior and to make adjustments for attributes if they're coming from other locations. So in most cases, you're going to have this type of relationship, which is indicated by a rectangle with no other icons. Now in some other cases, you may need to vary from the star in terms of the relationships. So let's take a look at one of those. So for internet sales order details, this relationship is actually from the fact table. So this column is sourced out of the fact table, and this is actually shown graphically through this picture here, and it says the dimension table is the fact table. So we have no granularity dimension table, so on and so forth, because it's just a column out of the fact table. Again, you want to be conservative about this because this adds to the width and the size of the fact table, which is normally one of your largest tables in your source schema. Now, in addition to this type of relationship, we have other types, and this relationship here between internet sales and sales reason is one of the most sophisticated types. This is a many-to-many relationship. So if we open this up and take a look, it looks pretty complicated, but it actually is something that all of you that are coming from relational database technology, which is probably most of you, will be very comfortable with. It's basically you have a join or a junction table. So the dimension table is joined to an intermediate fact table. The intermediate fact table is joined in turn to an intermediate dimension table to which the fact table is joined. So in this particular case, the dimension is sales reason, and we have an intermediate measure group, which basically is a table full of keys that allows a many-to-many relationship between sales reasons and the associated measure, which is internet sales. So a sale can have many reasons. This has been a great enhancement to the product that was introduced in the previous version, and it's something that when I was the BI architect I actually used frequently. In addition to these types of relationships, I'll just open up a regular relationship so that you can take a look at the others that are available. You can specify no relationship, and that would be a gray triangle. You can specify a referenced relationship, and that would be multiple source tables, which is called a snowflake. Or you can have a relationship to a data mining model. If you wanted to add a new relationship in this particular section, you would simply go to the source dimension and the measure group, and then you would set up a relationship through this section here. If you wanted to add a new dimension and then to establish a relationship, you would simply click on Add Cube Dimension, select the dimension, and then click OK. And you notice because geography's already been listed here, it says geography 1. Now, an interesting use of this that commonly is used is around time. I'm going to go ahead and delete this. For example, you might want to have more than one instance of a time dimension, and here we have a good example of this. We have the date dimension, and then we have the date dimension aliased as ship date and delivery date because we want to have those aspects of the date all available from the cube. Again, this is a very, very powerful designer, and when you're new to the world of OLAP, this is a place where I found many people become slightly confused because it's not a relational type of modeling. So I would recommend that you spend quite a bit of time in the sample here understanding why, for example, the reseller sales has a relationship to the geography dimension, but the internet customers measure group does not have a relationship to the geography dimension. Once you're comfortable with these aspects of modeling, you're going to have a much greater success building cubes that are effective with your end users.